Hi everybody, this is the Unit 0 practice exam. This one reads practice exam B, or actual exam B, but again, the real exam should look just like this, except with some numbers changed. So let's get to it. How do I do this first problem? We're given 2 points. In case you can't see from the point of view, it's -3, -4, and 12, 5, right? So we got these 2 points in space. First question, tell me the midpoint between those 2 given points. So by this point, we should be using the midpoint formula to figure this out. The midpoint formula is as follows, right? To find the midpoint between any 2 points in space, simply add the x coordinates together and cut it in half, add the y coordinates together and then cut that in half. Okay, so let's do it. For this, the x coordinate of the first point is -3. The x coordinate for the other point is 12, so we're going to add those numbers and then cut that in half. And then for the new y coordinate, for the midpoint, right, we're going to take -4, that's the y coordinate of the first point, and we're going to take +5, the y coordinate of the other point, and add those together and then cut that in half. Okay, so then putting that together, -3 plus 12, I believe that is 9. So 9 is going to get cut in half in a moment. And -4 plus 5, that makes 1, so that's going to get cut in half in a moment. Okay, so actually that's an acceptable answer, 9 halves and 1/2. But for you decimal aficionados, we could say, okay, 4.5, 0.5. Okay, so that would be our answer for find the midpoint. So when you do this on your exam, again, follow the midpoint formula. Again, you don't have access to your formula, so make sure to do enough practice so you know what you're doing. Okay, for the other problem, find the distance between the 2 points. We'll do the same 2 points, but now we want to find the distance. For the distance formula, d, right? The idea is we're going to take -3, the x coordinate. We're going to take 12, the other coordinate. We're going to figure out how far apart they are, so subtract. We're going to square that to get rid of any negative numbers that might come up. And then we'll do the same thing for the other one, okay? So we have -4, we have regular 5, we're going to subtract them to figure out how far apart they are, we're going to square it, and then we're going to add that together and finally take a big square root of everything, okay? If you Google this, the distance formula again is the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? But as we've been doing in the class, we're just working with numbers most of the time. So what are we taking the square root of? The square root of -3 minus 12, well that's -15 squared, and then plus -4 minus -5, that's -9, and that's getting squared. Okay, so what we'll do in a moment is take the square root of these numbers. -15 squared is the same thing as 15 squared, because -15 times -15 is +15. 15 squared, I believe, is 225. 9 squared, or -9 squared, is the same thing as 9 squared, so that's +81. So therefore, my final answer is whatever the square root of 225 plus 81 is. I think when we add that together, that ends up giving us a 6, 0, and a 3, so 306, the square root of 306. Okay. So if you have a calculator, you would figure out the answer, but I also accept that as a final answer, the square root of 306. Okay. All right, moving on. When we get to the next couple of problems, I'll do these in orange, let's say. We are looking at the equation of a circle, okay? So a reminder, the equation of a circle looks like this. There's an x minus k squared plus a y minus h squared equals an r squared, where by switching the values on k and h, k comma h tells me the coordinates of the center of the circle. And when I look over here where it says r squared, r, just r but not r squared, is the radius of the circle. Okay, so let's make sense of that in these 2 examples. I'm going to do this in green. So for the center of the circle, notice in 3a, unlike 3b and 3c, we are missing a minus or a plus. So there's nothing there. So that's telling me that k and h have to be 0. So the center is 0, 0. Okay. When I look at the radius, I have a number 9. And I want to write it as something squared. So I think to myself, what number, when I square it, gives me 9? What times what is 9? Oh, I know, that's 3. 3 squared, okay? I can do that with all the rest of these numbers. What is 81? It's just 9 times 9, 9 squared. And what's 144? Well, that's just 12 squared, okay? In case you have trouble figuring out what those numbers are, the trick is, if you have a calculator, take the square root of this number, square root of 9, square root of 81, square root of 144. That'll produce that 3, that 9, and that 12, okay? So keep in mind, right? The 3, the 9, and the 12, those are our radiuses, okay? So over here, I'm going to say the radius should be 3, the radius should be 9, and the radius here should be 12, okay? Let's finish this problem, though, by putting the coordinates at the center for the other couple problems. The coordinates at the center for this problem are positive 2, comma, minus 5, right? And this one should be minus 2, comma, positive 10, okay? So I'm just doing what I saw from the original formula. I'm taking each number in here and switching its sign. So if it was negative, it's positive. And if it's positive, it shows up as negative, okay? So those are those there. Let me highlight those there for you viewers at home. Radius of 3, 0, 0. Center 2, comma, minus 5, 9. And negative 2, comma, 10, 12, okay? Okay, question 4. Write the equation of the line in slope-intercept form that passes through these 2 points. Okay, so first of all, we need to dissect this, right? Slope-intercept form is an equation written as y equals mx plus b, where m is my slope and b is my y-intercept, okay? So I would have completed this problem once I am able to write y equals a number x plus b, one more number. What is the slope between these 2 points? Let's calculate it. Slope can be thought of as how much did I rise from one point to the next and how much did I run from one point to the next. So let's start with this point here. If I'm at negative 12 and I end up at negative 3, how much did I run, right? Think of a number line, negative 12, and you go all the way to 3. How many steps to the right did I take? And pause the video if you need to do that. Maybe take out a piece of paper and write it out. Negative 12 to negative 3, that's 9 steps forward. So I'm going to put plus 9, right? For my rise, I look at the y-coordinates. If I started at a y-coordinate of 5, and now I'm at a y-coordinate of 4, I went down by 1, so I'm going to put minus 1. Okay? So my slope is negative 1 over positive 9, or just negative 1, 9. Okay? So what I know now is, okay, for this equation, let me write that here on the side. Y equals mx plus b. I know the value of m now. It's negative 1, 9. I'm going to put the x, and then I'm going to put the plus b. So again, I know I'm done with this problem when I'm able to tell you what m is and tell you what b is. I just need to figure out what b is. And for this, again, let's go back to Algebra 1. If I know an equation with 1, 2, 3 variables, but I know 2 other knowns, I can plug any of these numbers in to simplify it so that b is the only unknown. I'm going to plug in this one here, negative 3, comma 4. So x is negative 3. Y is positive 4. Okay, and so I make this new equation. I just plugged in negative 3 where x is, 4 where y is. And let's simplify this a bit. I'm saying that 4 equals negative a ninth times a third. What is a ninth of a third? Well, negative and negative make positive. It's just 3 ninths, right? Plus b. And if I simplify my fractions a bit, 3 ninths is the same as 1/3. So it's 4 equals 1/3 plus b. Therefore, if I want to get b by itself, I could subtract the 1/3 from both sides and figure out that b is whatever 4 minus a third is, right? And if we interpret 1/3 as 0.33, because that's what a third is, we can think of this as, that leaves us with 3.67 at the end, okay? So our b value is $4.67 because a third is kind of like 33 cents, so we're subtracting that from 4, okay? So overall, my final answer for part 4, what is this equation? I'll write that in black here. I would say it's y equals the m, which is negative 1/9, x, and then plus b, plus 3.67. Okay. All right. So going back to the next couple problems. Problem 5. Write the equation of the line in point slope form with slope negative 2 and that passes through 2 comma negative 10. Again, important to dissect the important word here, point slope form. Point slope form is an equation written in this form. Y minus y1 equals m times x minus x1. Okay? We must commit this to memory so that when we face it on the exam, we know exactly what to do. So anytime you do practice problems, practice writing that out. It'll help it stick. Okay, so when are we done with this problem? You're done with this problem once you tell me what the m is, the slope, and what the x1 and the y1 are. Okay? Luckily for us, this is a very straightforward and easy problem. The m, they told us, m represents slope. The slope is -2. x1 and y1 are the coordinates here of this given point. So how should this show up? We're going to write it like this. Y, and we have the y1 here, but notice there's a negative sign. So that tells me you had to have switched the sign on it. In our given point, it's written as -10. So in here, I'm going to write it as +10. Okay? That way I know if I was looking at the equation, that's what the actual point should be. It switches signs. I write equals m. M is the slope, so I'm going to put that number -2. It's there. And then I'm going to do my parentheses. X minus, and then I have the x1 here. The coordinates of the x coordinate. The coordinates of the x coordinate are +2. So I know here I should have to write it as -2. That way I know if I switch this, I actually get back the real coordinate. Okay? So there we go. The equation of a line in point slope form with slope -2 passing through 2, -10 is simply this. Okay? So yes, I am a fan of point slope form. It is so much easier to work with than slope intercept form. I wonder why we always do this in Algebra 1 instead of that in Algebra 2. Okay, moving on. Question 6. Write the equation of a line in slope intercept form parallel to this, passing through this. Okay, so again, the key word here is slope intercept form. We know again that slope intercept form, like problem 4, is y equals mx plus b form. Okay? I need a slope and I need a y-intercept to be done with this problem. So let's read what we have here. The word parallel means if we have two lines, they're never going to touch. What does that mean? It means they have the same slope because they always have to run in tandem to each other. So the m for this equation needs to be the same m that I have in this equation. But we just saw in problem 5, the slope in point slope form, the m here, shows up on the right-hand side, right before the x minus the x1 part. So the slope is a third. So if I want this new line to be parallel, they need to have the same slope. That's why my next step, I'm going to add in that known now. The m is 1/3. Y equals a third x plus b. Okay? So since it's in slope intercept form, I need to know the slope and I need to know the intercept, the y-intercept. I need to know what is b in this case. So just like before, I need to plug in that extra point to just figure out what b is. So that's where this comes in. I want it to pass through 2, 12. So that means plug in 2, plug in 12 into here. Okay, so I'm going to plug in 12 equals 1/3 x plus b. X is 2 here. Right, so I should be writing 12 equals 1/3 times 2 plus b. So therefore, if I work out my math, a third of 2 is, well, 2/3 plus b. If it helps, right? 2/3 is, as we saw before, it's 0.67 cents about. So we're saying 12 equals 0.67 plus b. So therefore, to get b by itself, I'll subtract the 0.67 from both sides. And I think that'll leave me with $11.33 for b. Okay. So now that I have the b value, I can just go ahead and finish and say, okay, you wanted the equation? Here it is. Y equals mx plus b. Y equals 1/3 x plus 11.33. That would be my equation there, okay? And I'm going to highlight that for you so that hopefully you can see it a little better on your screen, okay? There we go. All right, we're almost done. We're at problem 7. It says here, can you write me the equation in point slope form perpendicular to this stuff passing through this point? Okay, so again, key word. They want it in point slope form, so let's write that out. Point slope is y minus y1 equals m times x minus x1. This is the equation I want to work with. I want to figure out what is m and what is this x1 and y1 business. Okay, this time, let's see if we can figure out the m just like we did before. They want it to be perpendicular. So unlike parallel lines, perpendicular lines do touch, but the way they touch makes a 90-degree angle. For that to happen, I need the slope of this to be the opposite reciprocal of the other slope. For example, right, if my slope is run 1, go up 2, run 1, go up 2 to make this line, a perpendicular line needs to be doing the opposite thing. It needs to be going down by 2 for every one I go up, so that they actually cross and make that line. So a reminder, perpendicular lines have opposite reciprocal slopes. So when I'm building my equation, I could write it like this. Y minus y1 equals, what's the slope of the given thing here? 2/5. So the perpendicular slope would have to be, take the 5, put it over the 2, add a negative, because that's a positive slope, so I need the perpendicular slope to be opposite and reciprocal, okay? Opposite as in negative when the other one's positive, reciprocal as in switch the fractions, okay? That said, I'm going to put my parentheses x minus x1, okay? So I have that slope, it's perpendicular, and I needed to pass through this point, minus 2 comma 4. So remember, when I work with point slope, because of the little minuses here, I need to switch the signs on my final equation. So it's simply y minus y1. y1 is positive 4 here, so this is going to show up as a negative 4. And x1 is minus 2, so it would be like x plus 2, because it has to be the opposite of that. And that's the answer for number 7, okay? So again, I started with the given form that they wanted, point slope. I wrote that down. Y minus y1 equals m times x minus x1. They told me a detail about that slope. Did they want it to be parallel, perpendicular, the same? Perpendicular, so I took that number, and I know the perpendicular means the slopes are going to run opposite ways. So instead of going 2/5, it's 5/2, but negative. Last but not least, they needed to go through this point, so that's where I put in the points by switching the values, okay? All right, last but not least, how do I do these last couple problems? Question 8, can you write this in interval notation? When I read this, it says x is less than 10, right? Because the arrow is pointing towards the 10. It can also be equal to 10. So putting that together, we're saying x is all the numbers that are equal to 10 or less, okay? So in interval notation, that would be written this way. 10 is my rightmost point, and then I got to think about my leftmost point. It goes left, right like this. I can include the 10, so I'm going to put a bracket on there, and I think of all the numbers that are less than 10. Think of it, 9, 8, 7, 6, eventually 0, eventually -1, -2, -3, -10, -100, all the way to -infinity. So in interval notation, the answer to question 8 would be -infinity up to 10. These are all the numbers that are less than or equal to 10. Okay. Number 9, write this in interval notation. This says x is a number that's less than or equal to 12, right? But it's always bigger than 10. So here, my left and right are a bit more clear. I would write 10, comma, 12, right? And here I gotta think, can I include the 10? Can that be equal to it? It can't. So I put a parentheses, okay? That's why I put a parentheses on the -infinity, because you can't actually reach infinity or -infinity. You can get close to it. That's what the parentheses tells me. But for the 12, I can actually reach the 12 and x can actually be equal to 12, so I'll put a parentheses there. So that's how I would write that in interval notation. Okay. Last but not least, for number 10, I'll do that in purple. Write x is less than 1,234 in interval notation. So if you notice, this is very similar to number 8. We're saying, if we're thinking left and right, the most right I can go, the farthest to the right I can go is that 1,234. I can't actually be equal to it, so I put parentheses. And I think of the leftmost value x can be, what are all the numbers less than 1,234? If you take a moment to think about it, it should be, again, -infinity. Because there's an infinite amount of numbers that are less than that. So this one will be written this way, okay? So when you think of your interval notation and when you study for it, remember the difference. Parentheses mean you can get near the number but not actually be the number. If you can be the number, you can equal it. We need to put a bracket. That's when the little equal sign shows up on the inequality, okay? And that's how I would do that first practice exam, okay? From the first exam, okay? So things to study are in interval notation, the 2 different equations for writing a line in y equals mx plus b and point slope form. Recognizing the structure of the equation of a circle as switching numbers. Things are being squared, and the radius is the square root of the number here. And last but not least, the distance and midpoint formula, okay? So before you take it, make sure you've studied, you know those formulas, you know how to apply them in the moment, and you can check your work, obviously, okay? Thank you for your time. Bye.